In this example, we're going to look at a relationship between pressure and temperature using the Guy-Lussac law. So the question says, 10.0 liters of a gas is found to exert 0.957 atmosphere at 25 degrees Celsius. What would be the required temperature in Celsius to change the pressure to standard pressure? So the first thing you'll have to remember is back in chapter 8.1, you learned that standard pressure means that we are looking at 1 atmosphere. Now let's read the rest of the problem. We have a volume. The reason we have a volume is so that we know volume is constant in this problem. Really, we are looking at a change between atmosphere, which is our first pressure, a temperature, which is our first temperature. We are looking for the required temp, which is T2, knowing that we're going to go to, P2, which is our pressure. So let's write down what we know. Our first pressure is 0.957 atmosphere, and make sure you keep your units because we need to make sure that everything is in the correct units for this calculation to work. T1 is 25 degrees Celsius. Now we can't stay in degrees Celsius. We're going to have to convert here to Kelvin, and we do that by adding 273.15. So that's going to give us 298.0 Kelvin. P2 is our standard pressure, which we know is 1 atmosphere, so we need to solve for T2. So what is the relationship that we need to use? Well, it's P1 over T1 equals P2 over T2. So let's plug in what we know. We know P1. We know T1. Make sure you write that in as the Kelvin. We know P2, which is 1 atmosphere. And what we're going to be solving for here is T2. So we can do cross multiplication and say that T2 is equal to 298.0 times 1 divided by 0.957. So in your calculator, all you're going to do is take 298 divided by 0.957, and what we will end up with is 311.4 Kelvin, and the question was actually asking for degrees Celsius. So subtract 273.15, and that way our answer will be in terms of Celsius, and my final answer will be 38.2 degrees Celsius.